yesterday, we started talking a little bit about credit cards, and we said that there was this interest on a credit card called an APR, annual percentage rate. Okay, and that is just the percent of interest that you are charged on your debt throughout the year. Now, let's suppose that you charge $1,000 on a credit card. We're going to start with 1,000 because we're going to kind of keep it as a nice number as our starting amount. If you have 12% APR, let's find the account balance after 5 years. So this is what we did yesterday. How do we set up an expression to say what is the exponential model to find the account balance? That's what I'm trying to say. What would you write? What's your starting amount? 1,000. Okay, what will go in the parentheses is the growth rate here. Yeah, 1.12, right? 1 plus the 12% interest, and 5 will be our exponent. So pop down to your calculators there. Can you tell me, to the nearest penny, how much money will you owe your credit card company in 5 years if you don't pay off your debt? Shout it out, Lauren. $1,763.34. Yes, you guys agree with her? I agree too. All right, so that's what you'll owe in 5 years. Now, in the real world, so this problem that we just did, the way it's set up says that the credit card company charges you 12% interest one time during the year. So just once a year they charge you interest, and then the next year, 1 year later, they charge you interest. That's not how it really works. So this is a little bit more how it works. It says if interest were charged at 12% semi-annually, how often is semi-annually? Twice a year instead of once, the same card would charge 6% interest twice a year. Now, why would it be 6% interest twice a year? Well, how do I get the 6%? Yeah, 12 divided by 2, right? So the same 12% for the whole year divided into 2 parts. So let's figure out now, if they charge you interest twice for 6%, how much would you owe? So it sets up the same way. We start with $1,000. Bless you. What value is going to go in my parentheses this time? 1.06. Now this time I'm charging 6% interest twice a year. Now my exponent's going to be a little different because I'm charging it for 5 years, but am I only taking interest 5 times? How many total times am I taking interest? 10, which is 2 times 5. You can put 10 there, but it's 2 times 5, right? So 2 times a year for 5 years. Type that into your calculator. Tell me, sorry, I have pretty bad cold. How much interest you would be charged, Riley? Yeah, $1,790.85. Now, what do you notice about those two numbers, the comparison to each other? Higher. It's higher when we charged interest, even though it was a lower number for the growth rate. This interest rate ended up being higher, the total. All right, so that pattern, let's kind of discover it a little bit more, because we're going to discover a new formula today. But first we have to discover a pattern. So we're going to fill out this chart. It's going to take a few minutes. We'll kind of split up the work to go together. Let's make sure we know what the words mean here. What does annual mean? Once a year. So this, we're going to charge this 12% interest one time each year. Semi-annual, we just talked about how many times a year is that? Twice. What about quarterly? That'd be 4 times a year. How often would that be if you charge something 4 times a year? Every 3 months. Okay, how about monthly? How many times? 12 times a year. Okay, so this whole chart is going to be working with the same problem. You still have 12% interest for the whole year. So just like the first problem, if I charge 12% interest for the whole year and I charge it once, I'm going to charge the whole 12% at a time. Right? That makes sense? And just like the problem above, if I split that 12% over 2 times, what percentage rate are you going to use each time? 6%. Okay, how about if I split the 12% over 4 quarters? 3%. And the 12 over the 12 quarters? 12 months? 1% each time. Okay, does that make sense so far? Okay, now we're going to set up a lot of equations here. We're going to go one at a time now. We won't go down the table, we'll go across the table. So let's start with annual. We can actually copy a lot of this down from up above. So our equation here, the expression for the account balance after X years. Well, this is what we did yesterday. We start with our $1,000. We're charging 12% interest, so I'll have 1.12. and just to the x value. Right? That was the first thing we did. And we can actually copy the account balance after 5 years down into the table. So copy that right from above. That was 1,762.34. Now we don't have the account balance after 1 year. Can you look that up for me? If I put 1 in for x, how much money would you owe?
1,100.
Yeah, $1,120. So row 1 isn't too hard. The second row also shouldn't be too hard because a lot of it, again, is being copied down from above. So let's write our equation again. Y equals, we're still starting with $1,000. If I'm charging 6% interest, what goes in my parentheses? Yes, you're very vocal today, everyone. Now, what should my exponent be? It's not just x, because how many times a year were you charging interest? Twice. You have to say 2 times every year. So 2x is my exponent. Right? Now, just like up above, we already found this balance for after 5 years. And we said that that was $1,790.85. Can you figure out the balance after 1 year if we charged interest twice a year? What?
I think I have a mistake because I have 360.
Yeah, that's not right. For what?
Oh,
Okay.
You're right.
You're good. Okay, what do you guys get for 1 year? Yep, 1,123 and 60 cents. All right, now we have to do a little bit more work because we haven't done these guys yet. Quarterly and monthly. So quarterly, what equation are you going to set up here? Y equals 1,000 times 1.03. Now, what should my exponent be here if I charge it 4 times a year? 4x. Okay, let's split up the work. 2 rows by the window. I want you to find the balance after 1 year. 3 rows by the door. I want you to find the balance after 5 years. And we don't have to type quite as much in our calculators. So 1 year, 5 years, split up the work there. So we're charging 3% interest 4 times a year, which is total to 12% for the year. One year, people, what did you get? You have 1,125.51. You guys can copy that down. 1,125.51. 5-year people, how much money?
1,806.
You have $1,806.11. All right, what trend are you seeing through the table so far? It gets higher the more often they take interest. Yeah? Okay, let's do one more, and then we'll kind of tie it together. So what's going to be our equation? Y equals our starting value, 1,000. What goes in my parentheses this time? 1.01. And what's my exponent? 12x. Okay, same thing. Window people do 1 year. Door people calculate after 5 years. Hopefully you're getting bigger numbers than the one up above if you're following the same pattern. So 1 year people, what'd you get? Yeah, $1,126.83. 5-year people?
1,067.
All right. So obviously we notice that the numbers are going up, right? So that means the more often they take interest for your credit card, the more money they get. Which interest rate, how often do you think is better for the consumer? You. Just annual, right? This is the lowest one. So they only charge you interest 1 time a year. It's best for you. Which is best for the credit card company? The bottom one. So if you think, even just after 1 year, there's only about less than $7 difference between annual and monthly, right? But think about, like, millions of people have credit cards, right? So $7 for millions of people, that makes the credit card company a lot of money, right? All right, so over time, the more people that they charge this higher, more often interest for, the more money they make. Now from this, we can actually discover a new exponential formula for this specific thing called compound interest. Now, compound interest, what it is it's taking interest on interest on interest. So, like your balance doesn't always stay $1,000. They charge you interest on the previous year's new balance. Does that make sense? So it always goes up. So let's see what we come up with. All right, so we're going to use the letters A, T, P, R, and N in our formula. And I'll kind of help you out here. We're going to write A equals, that's the amount in your account, or just the amount, equals. So I use the A. Now, we have to use T for years. The initial charge, or what we call the principal balance, is going to be P. The R is the percentage rate, and N is the number of times a year. What do all these equations start with? The P, right? 1,000. So we're going to put P next. That's the amount that we start with. P. Okay, so use that one. That's good so far. Easy. Now I want to set up a big set of parentheses here. What do you notice is inside every set of parentheses? A 1 with a decimal after, right? So would you agree that, like what we did yesterday, this is all 1 plus some percent? All right, let's start with at least the 1 plus. I'm going to have 1 plus something. 1 plus some decimal. Now we have to figure out, how do I use the R, the N, and the T to do the rest of this? So any idea how I can get this decimal after the 1 with these letters? I'll give you a hint. If I looked here at the 12, we were dividing 12% just one time throughout the year, right? So I didn't really have to do anything to change the 12. What about the 6? How did I change this 12 to get a 6? 12 divided by the 2, the number of times we took interest. How about to get to the 3? It was 12 divided by 4. And then to get to 1, it was 12 divided by 1. How can I use that to come up with something to go in here? What's the 12? Which letter do you think it would be? Percentage rate or the number of times a year? That's the R, the rate. So you're taking the rate, the 12, divided by what? And the number of times a year you're taking interest. Right? So if I tell you we're taking 12% interest, 12 times a year, we have to divide those to get 1%. All right, we're almost done. We need an exponent. We know that T is going to go for time in my exponent, but I'm missing something. What else do I have to make sure is in my exponent here? The N, the number of times a year you're taking interest. That's your new formula. That is your, you can flip the page if you want. That's the formula for taking compound interest on a set number of times. What? N times T. NT. Right? So the reason this is different from the simple interest we did yesterday is the word compounded. All right? And as we go through the rest of the week, we'll kind of have to pick whether it's the basic stuff from yesterday or this, and the key word is going to be compounded. If it's compounded, you're going to use the fancier formula. So let's just do, we're just going to do 2 of the examples, and then I'll leave you alone. Okay? So let's make sure we can set this up. You owe $200 on a debt that has 16% annual percentage rate, compounded monthly. How many times a year is monthly? 12. Okay, so we're going to use 12 for our number of times. How much will you owe after 2 years? All right, so we'll set up our expression. A equals, what's the amount? So what's the principal here for P? 200. That's what you start with. Then you set up your big parentheses. My formula always has a 1 plus. Now, what's the percentage rate? 16. Now, it says here that the percentage rate has to be expressed as a decimal. So what's 16% as a decimal? 0.16 divided by the number of times you take interest. If it's monthly, how often is that? 12. And then 2 years. Well, my formula has, we have to use the N again, which is the 12, the number of times, times 2 years. Now, we're going to do this all in one step in our calculator. The nice thing is that you live in the 21st century and you have calculators to do this. When your parents were in school, they didn't have calculators that could calculate all this at once. They had to use tables. Like there was literally like tables in their books that were just like full of numbers, and they had to like look up all these powers and exponents and decimals. So let's save us some work. Does anyone not have a calculator that can make fractions that look like that? Everyone's calculator did that?
I'm able to use parentheses.
Yeah. Okay. Can you do that too? Alpha y equals enter. It's not like harder or any less easy, but it'll make it a little cleaner. Try it. Alpha y equals enter.
Alpha y equals?
Yep. And then enter.
Oh. No, just gonna do this.
Okay. So when you type yours in, I'll show you in a minute how to type yours in, Charlie. It won't be hard. All right, let's type it in. I would do it all in one step. So 200 times 1 plus big fraction 0.16 over 12. And you don't even have to simplify the exponent to be 24. If you wanted, you could just type 2 times 12 in your calculator, hit enter, and it'll give you the amount of money. Now, if you cannot make that fraction there, your calculator uses order of operations, so you don't have to do extra parentheses, Charlie. You can just type 0.16 divided by 12, just like that,
Oh, okay.
to the 2 times. Now, I would put the exponent in parentheses, though. If it doesn't do it, like as a caret, I would do parentheses 2 times 12. But other than that, you'll get the same answer. Okay, so you don't have to do extra parentheses.
Okay.
Right. Yes, we good. All right, so you'll be owing $274.84. Now I know you're gonna look forward to this, but in about a week, we're gonna be solving equations with all of these numbers in it, with like exponents and variables in them. You just imagine how much fun that's gonna be, how much writing that's gonna be. My hand always like starts cramping up when I do these a lot. All right, last one. So you have a savings account that has $1,500 in it. In a savings account, you get 4.7% interest. If they take interest compounded semi-annually, how much will you have in 25 years? All right, so let's write our equation. A equals, our principal is 1,500. What's going to go in my parentheses? 1 plus, what's 4.7 as a percent is a decimal? 0.047. How often are you taking interest? Twice a year. And my exponent is going to be 2 times 25. So carefully type that in and tell me to the nearest penny how much money you're going to have. This will be our last one. Anyone? There we go. So a lot of this will be just being careful typing in your calculator, like human error kind of mistakes, but we good? We like our new formula? We love it, right?